Hi, welcome to this talk on event sourcing with Amazon Managed Streaming for Apache Kafka. My name is James Ousby. I'm a Principal Solutions Architect with AWS based here in Sydney. I work in our financial services team, helping Australia's banks and insurance companies get the best use out of the AWS platform. So given the finance background, I'd like to explore with you today a sample banking application that demonstrates how you might implement event sourcing on the AWS platform by building on top of Amazon Managed Streaming for Apache Kafka. My learning objectives for this talk are the what and why of event sourcing and how Amazon Managed Streaming for Apache Kafka can help. I'd like to encourage you to think differently about how you capture, store, and process your data. And I'd like to explore the design and build process behind an event sourcing demo built around MSK. So what is event sourcing? A good place to start is by comparing it to what it is not. In the world of relational databases, you'll often see a pattern where you persist entities by updating them in place. Here we have an invoice record. It's got 3 columns, and we've got a status of issue to start with. 30 days later, we run a job that identifies that invoice hasn't been paid yet, and we update the status in the row in that table to overdue. 10 days later, the customer pays that invoice, and again we go in and we update that column in the particular row to paid. One potential issue with this approach is that we've lost some of the rich history of this entity over time. The fact that this invoice was in a state of overdue for a period of time is useful information to me. I may want to run some analytics down the track that identifies which customers have trouble paying on time. Let's compare that with the approach taken by event sourcing, which is to store an ordered sequence of state-changing events. So we start off with an issued event where we create our invoice with the same columns we saw before. And from that issued event, we can maintain a running point-in-time snapshot or summary of what the invoice currently looks like. 30 days later, we run the same job that identifies that this invoice is currently overdue. And we create an overdue event that updates the status to overdue. And we update our running summary or snapshot with that information. And then finally, 10 days later, we create a paid event that updates the status to paid. And we update our running summary with the status of paid as well. So with this approach, we've got a complete history of this entity over time. This allows me to run analytics on all the data that we have. And interestingly, it also allows me to rebuild that summary snapshot by replaying the events in order. So if I want to present this data slightly differently to a different set of customers, I can maintain 2 different presentation layers, or if one became corrupted, I could rebuild it from a replay of all the events, as an example. At this point, it's worth pointing out that event sourcing usually comes as part of a package deal. There's usually a few other patterns and designs that you'll see used in conjunction with event sourcing. First one being domain-driven design. So domain-driven design is a software design philosophy that focuses on the domain model behind your application. A lot of the terminology that you'll encounter in reading about event sourcing and looking at event sourcing frameworks comes from the land of domain-driven design. So if you're having trouble understanding some of the concepts or terms that you see in relation to event sourcing, it may be worth having a read on domain-driven design to see if some of the concepts in that space shed some light. The second pattern here is command query responsibility segregation. So this is a design pattern that allows you to separate your read and write paths for data. Event sourcing is a really neat way of helping you achieve that. And then finally, distributed logs is usually the way that people look to implement or store the events that are generated in an event sourcing approach. A bit later on, in another section, we'll talk about why distributed logs are useful for event sourcing, and in particular, Apache Kafka. So why event sourcing? The thing I like most about event sourcing is its ability to help future-proof your data architecture. At Amazon, we have an internal concept or mechanism called one-way and two-way doors for helping with decision making. And the idea behind this is that are we making a decision here that we can potentially come back from in a reasonable, pragmatic way down the track. Where possible, we would like to make a two-way door decision that we can come back from, as opposed to a one-way door decision, which may have more rigor and data behind it. I would argue that event sourcing, with its approach to maintaining a complete history of data and the ability to replay it, helps you from having to make a one-way door decision about your data. Additionally, it's increasingly difficult to anticipate the long-term data usage patterns at the design and build time of your application. If you were designing a data architecture 5 years ago, it would have been hard to anticipate the rise of the need to use that data for training machine learning models, as an example, or the rise of production grade NoSQL graph database solutions that you might want to be taking advantage of now. And on that point, you would like your data architecture to support new patterns of consumption as technologies evolve over time. So every year, the AWS platform is adding new services, and every year we see new services in the data space in particular. You'd like to be able to leverage these as they become available. As an example here, we have a diagram that is showing I'm capturing my events, I'm storing that in Amazon Managed Streaming for Kafka. And from that, we have multiple consumers that can be building up a view of those events in Aurora as a relational model, Redshift as a data warehousing model, DynamoDB for a key value store, and Elasticsearch for non-structured text-based search. And then as new services become available on the platform, Amazon Neptune is a graph database that was released a couple of years ago. I can then add another consumer to that event stream that can go back to the beginning of time and build up a graph model of my data if I like. So a common theme you'll hear in Amazon data and analytics talks is the idea that you should capture your raw data, store that in a data lake to help preserve and be able to reprocess that data later on. I'd argue that not all approaches to capturing your raw data are equal though. I think the approach that event sourcing provides makes capturing raw data easier to replay and reprocess over time. So what I'm trying to say here is don't just tick the box on capturing your raw data. Give some more thought to how you might capture that raw data in a way that makes it easier to manage over time. And then another major benefit is event sourcing, CQRS together provide some really neat architecture benefits. So here you see an architecture diagram that is representative of the demo that you're going to see later on. So we have a set of containers that back our write path that are running in AWS Fargate. From those containers, we process the commands that come in from the client on our write path, and we store the events that are generated from those commands into Amazon Managed Streaming for Kafka. We then have a set of containers that process those events and builds up our summary view in Amazon Elasticsearch. And then we have a separate set of containers that back our read path that read the data from that Elasticsearch database and present it back to the consumer. So these patterns allow you to scale both elastically and independently the write, read, and processing of those events. And not just scaling either. So you can prioritize or provide quality of service for a particular path. So if guaranteeing that the write path for your application has a certain level of latency that is impacted by readers, you can achieve that with this pattern. And then finally, you can also separate the development efforts here cleanly around technology stacks. So if you had a set of developers that are experts in Elasticsearch, they can build the read view from Elasticsearch without having to know about command processing and Amazon Managed Streaming for Kafka. So why not event sourcing? What are some of the challenges here? So firstly, it's not a new concept. Why isn't this the default way to think about your data? So firstly, platform tooling maturity. So some of the tools we're talking about today, they weren't around 10 years ago. They're only just sort of getting to the point where customers are feeling comfortable to use them at scale in production. There is arguably a lack of framework support, so there's no killer framework like Spring and Hibernate on the JVM platform that has really taken off and won hearts and minds. And previously it was considered more complex. There's more moving parts in an event sourcing CQRS approach to data processing. I would argue though that with infrastructure as code and the level of automation that you can achieve on the AWS platform, that some of the complexity here is going away. It's much easier for a small team to manage more moving parts on the AWS platform. And the benefits you get from these architectures are becoming increasingly more important as data becomes more important over time. So before we jump into the demo, let's have a chat about what Amazon Managed Streaming for Apache Kafka is. So Apache Kafka is an open source stream processing framework originally developed at LinkedIn and now donated to the Apache Software Foundation. The primary concept behind Apache Kafka is a distributed, immutable, append-only log. So producers add messages to topics. Messages are guaranteed to be ordered in a certain way. You can't go back in time and edit messages. You can't insert messages into a certain spot in the previous entries. You can only append to the end. And then consumers can make their way through that ordered sequence of messages at a rate of their own choosing. And you can go back to the start and replay if they like. So this is ideally suited to the event sourcing concepts that we talked about earlier. And we look at multiple consumers here. We've got this diagram we saw earlier. All of these consumers can be at different log offsets, where they're up to in processing a particular topic in Apache Kafka. But running Apache Kafka is not the easiest thing in the world. So a lot of our customers have had challenges running large-scale Apache Kafka deployments on AWS. Getting it set up is difficult. Achieving the availability that you'd like is difficult. Scaling all the nodes in and out, the ability to monitor it in the same way you can a relational database. And generally there was a support team around it that was needed just to run the platform. So Amazon Managed Streaming for Apache Kafka is a fully managed and highly available Apache Kafka service from AWS. It's fully compatible with the Apache Kafka open source project. There's multiple versions of Apache Kafka you can run. It's fully managed. We'll provision the cluster for you, help you configure the cluster, help you do maintenance on the cluster. It's highly available, so it runs across multiple availability zones within the AWS, within an AWS region. And it's highly secure, so there's multiple layers of security for locking down your Apache Kafka cluster. So if you're familiar with AWS, this diagram is what it looks like in terms of your software-defined networks. So on the left, we have a customer VPC or software-defined network where the producers, consumers, and management nodes for talking to an Apache Kafka cluster would run. And then the Amazon managed service for Apache Kafka effectively runs in its own managed VPC. The service will run a cluster of Zookeeper nodes for you in a highly available way. We run the Kafka broker nodes in a highly available way. And then we present that to the customer's VPC or software-defined network as some endpoints that can be called. And then recently, re:Invent last year, we announced open monitoring with Prometheus. So this is an additional capability for taking advantage of Amazon MSK to use Prometheus to do monitoring of the metrics that come out of Apache Kafka. And getting started with Amazon MSK is easy. It's fully compatible, as I mentioned before. There's multiple versions there. The AWS Management Console and API can be used to spin up and manage your cluster. And there's deep integration with other AWS services for monitoring and processing. Okay, so let's have a look at the demo. As I mentioned at the start, we're going to be having a look at a sample banking application that allows you to create accounts and deposit and withdraw money. The design process behind building this demo and event sourcing applications in general kind of looks like the following. And there's some key terms I want to get you across first. So commands, these are the instructions that your application would issue to the event sourcing system. As you process commands, you turn them into events, which are immutable facts or a sequence of state changes. And then we have an aggregate, which is our built-up view of our entity. And then a projection or materialized view is the view that we build from our event-sourced sequence of events to present to consumers downstream. So in our example, we're using Elasticsearch as our read store. So we have a projection processing framework that reads our events from Kafka and stores it in Elasticsearch. But you can use any sort of downstream presentation layer that you want. And then on the right here, we have the sort of general design approach. So you model your domain as a series of commands, events, and aggregates and views. So you need to make sure that the events that you are generating line up to create a fully formed aggregate, and you have the complete history of your aggregate or entity. You need to decide which views you want to use, which view technologies, Elasticsearch in this case. And then you go and design the command handlers to have a think about the code that would generate the events that you need and stores them in Apache Kafka. And then you design the event processes on the other side of Apache Kafka that will create your projection. And then finally, you design the read side that would read the data from that projection or materialized view. So at this point, I'd like to introduce Simple Machines. So Simple Machines is a leading Australian technology consultancy at the intersection of data architecture, data engineering, and enterprise software delivery. The company specializes in engineering real-time data-driven platforms and applications. And interestingly, they have 2 open source projects available on GitHub that you can have a look at. First one being Simple Sourcing, which is an event source data abstraction built on top of Apache Kafka. So we're going to be having a look at that in the demo today. It helps with the command handling part of your write path. And then there's Simple Saga, which we're not having a look at today, but you can check out in your own time. That helps you with distributed transactions. And this is our demo architecture. So you saw a version of this diagram earlier. Just to quickly recap, we've got a separate read-write path that's supported by containers running in AWS Fargate. So the write path takes commands, stores that in Apache Kafka as a series of events. We then have our projection service read from Apache Kafka, store that into Elasticsearch, and then our read side reads from Elasticsearch and returns the data to the client. So if we break that down a bit further, the client issues commands. The first set of containers contains our command handling code, which generates events and stores them in Kafka. We then have our event handlers, which reads events from Apache Kafka and creates our projection in Amazon Elasticsearch. And then we have our final set of containers, which reads our projection from Elasticsearch and returns the data to the consumer. Okay, time for some code. So what I'd like to show you first is the application functionality. So for this sample application, there's 3 main functions you can perform. You can create accounts, you can deposit money and withdraw money from an account. So here we have the create account screen. I'm going to create a new account with an opening balance of $3,000. We jump back to our list of accounts. We should see our new accounts turned up with a balance of 3,000. And there's a couple of accounts I've created previously. I can now go into these accounts. I can deposit some more money. And I can withdraw some money. Cool. So I think most developers at this point would understand how they would implement this with a relational database. But what we're going to explore today is how this might look using event sourcing and the architecture that we saw earlier. So next I'm going to show you is the application project itself. So it's a Gradle-based Java project. It's a multi-module project, and we have 3 submodules that represent the 3 container services that drive our architecture. So we've got a write API, the read API, and a projection service. And then interestingly, we have a CDK infra and CDK pipeline. So these 2 things, so last year I did a talk at Sydney Summit on the AWS Cloud Development Kit, which is a means of creating your infrastructure from code or describing CloudFormation stacks from code. And I talked about creating both a pipeline definition and an infra definition. And this is one way of addressing some of the extra moving parts and complexity that comes with an event sourcing architecture. So you can automate and manage this on your own. Hopefully I'll demonstrate. So we have a file here that talks to the pipeline that runs and builds my application. So I've got a pipeline definition here in code that has a source stage, a Docker stage that goes and builds my containers, publishes them to ECR. And then I've got a stage that takes my infrastructure definition, turns that into a CloudFormation stack, and then I've got the CloudFormation deployment stage. So we have a quick look at what that looks like in the AWS console. When I deploy that pipeline definition using CDK, you'll end up with a pipeline definition here that does what we saw in the description. I've got a source stage that's listening to my GitHub repository for any changes and will rebuild when it detects one. Builds my containers, publishes them to ECR, and then it goes and stands up the infrastructure definition. At the end of that, I'll have 2 CloudFormation stacks. So there's the CloudFormation stack for my pipeline itself, and then there's the CloudFormation stack that the pipeline builds and deploys, which is the infrastructure one, which has my containers, the Kafka cluster, and the Elasticsearch cluster. So if we jump into those services quickly, you'll see I've got a 3 ECS Fargate services running, representing the read API, write API, and projection service, and a task for each. I've got a Kafka cluster that's been stood up, and I've got an Elasticsearch cluster that's been stood up as well. So, with a relatively small team, you can manage a much larger and more bigger number of moving parts. Okay, so let's jump back to the code. So we have our read, write, and projection service. So the write path is probably the most interesting. So this is where we are processing our commands, turning them into events. So we have a class here that kicks that all off. And the first thing I want to point out is, once I've stood up my Kafka cluster, you then have this code here that uses the AWS SDKs to go and retrieve the list of broker nodes from a Kafka cluster ARN, which gets injected into the container as part of the CloudFormation stack definition. So this is how my container discovers my Kafka cluster. Then we jump into where simple sourcing library can help. So the primary goal of the write API is to take commands, process them, turn them into a series of state-changing events. And what this library is trying to do is remove what we call the undifferentiated heavy lifting. So serialization of your messages, the communications comms with Kafka, and lets you focus 100% on building just the command handling code. So we have an event sourced app class here that is effectively pulling this all together. We have our serializers, we have our nominated command handler, which is the bulk of what the read API is about. So let's go have a look at that one. So our command handler knows how to process three types of commands, as we mentioned. There's the create account, there's the deposit command, and the withdraw command. Now, interestingly, each of these command handlers comes with what is the command we're about to process, but also it comes with what is the current snapshot or aggregate view of the entity that we're going to affect. So this is useful for doing things like error handling and validation logic. So an interesting one is the withdraw. So I can take the current balance from the current aggregate, and I can check to see if the amount that we're trying to withdraw is going to push this account into a negative balance and fail it. So this is how you do validation and error handling within an event sourcing, eventually consistent approach. So this is another area where the simple sourcing library helps you. It helps, there's a mechanism for maintaining this aggregate or the current snapshot for use when you're processing your commands. And if we have a look at what those commands look like, so part of the design process we talked about was, modeling your commands and events. So we have an account command entity here. Three types of commands: the create account command, the deposit command, and withdraw. And they're fairly simple. As you can see, the create account has a name and an open balance. Deposit takes an amount, and withdraw takes an amount. And then we have the resulting events modeled as well, which are fairly simple again. So we have an account created event that gets generated from the create account command, which has the account name, the opening balance, and the time it was created. Similarly with deposit and withdrawn, we add in the time that these events occurred. So off the back of that, we've got our right path covered. We then have a projection service that processes these events. And we have two projections. There's two consumers here of the events. One builds an account summary view in Elasticsearch. The other one builds an account transaction view. If you have a quick look at what one of these looks like. So it has a pattern match here where it takes in the event and then based on which type of event it is, it will update Elasticsearch accordingly. So for withdrawn, deposited, and account created, it goes off and makes a call to Elasticsearch to update that index with, in this case, it's the account name, balance, and sequence. Okay, and then finally, after we've got our Elasticsearch indexes updated, we've got a really simple read API. So the read API is fairly straightforward. You have a set of endpoints that are presented using the Java Spark framework, which is a really simple HTTP REST API. And it goes off and calls Elasticsearch to retrieve the data when these API calls hit. So there you have it. We have our three services for processing commands via the right path, reading us projections or materialized view from Elasticsearch, and for building our materialized view or projections in Elasticsearch. And we have a automated infrastructure as code approach using CDK to make it easier to manage all these moving parts. So in closing, I'd like to quickly recap what we covered today. We've had a look at the what and why of event sourcing as a data architecture pattern. and we've explored how Amazon Managed Streaming for Apache Kafka can help you. Hopefully you feel encouraged to think differently about how you capture, store, and process data in the future. And we've had a look at some of the design considerations behind building an event sourcing application. Thank you for joining this talk today. I hope you feel inspired to consider event sourcing for a future application build. As we move towards a more real-time and event-driven approach to building software, I believe that event sourcing as a way of processing and storing your data will become increasingly relevant and well supported. As mentioned in the talk, if you'd like to have a look at the source code for the demo application, a link to the GitHub project will be shared in the follow-up material. Please enjoy the rest of your conference.